Assalamualaikum and hi to everyone that is watching this video right now. So now our group will present the sensing element. Before that, I would like to introduce our group first, which consists of 5 members, which is me, Muhammad Isyraf bin JAAFRI, and then NURIN NABIHAH binti SALLEHUDIN, AHMAD HAFIZ bin Muhammad FAIRUZ, Muhammad ALIFF bin Muhammad YUSOFF, and AZIEMAH binti AZMI. So let's get started with activity 1 first. Sensing element for automotive application, which will start by AHMAD HAFIZ bin Muhammad FAIRUZ.
Basically, I will explain about the sensor first. A sensor is an electronic component, module or subsystem that purpose to detect events or changes in its environment and send the information to their electronic to make a process. So, I will talk more about the resistive sensor. Resistive sensors are the sensors or resistors which detect the changes in their resistance, accordingly monitor or reacted to perform tasks. And what is resistance? Resistance is an electrical quantity that measures the electric current flow through it. And there is so many types of resistive sensor. For example, firstly is photoresistor. Photoresistor is an electronic component that detects the presence of visible light. And one more thing about photosensor is will react when have change on the resistant brightness. Secondly is about the thermistor. It's all about a temperature sensor that constructed of semiconductor material, and it will change if the temperature change to give a reaction. And lastly, about the flat sensor. Flat sensor, also known as bend sensor, is a sensor that measures the amount of deflection or bending, and this sensor usually stuck to the surface, and resistance of the sensor element is varied by bending the surface. Next is about the principle of resistive sensor. The conductor length is directly proportional to the resistance of the conductor and is inversely related to the area of the conductor. L is denominator for conductor length, A is for the area of the conductor, and R is for the resistance of the conductor. Rho is the resistivity, and it is constant for the material used in conductor construction, and its formula is R equal rho L over A, where R is a resistance of conductor, A is area, L is length, and rho is resistivity. And this is the formula of this resistive sensor. If we need change the resistance of material, we have to change the value in the principle. For example, when the length is modified, we can change the resistance directly. So if we doubling the amount of the length, it will double the resistance. If we decrease the length, it will decrease the resistance. How about we change the area? If we change the area, the resistivity will cut into the half, and changing the conductivity and temperature will not affect to the resistivity. So that's all for me. Thank you.
So now let me explain about how does a resistive sensor operates. As we all know, the resistance of a material depends on 4 factors, which are the composition, length, temperature, and cross-sectional area. To change the resistance of a material, you must change the value of one of the factors mentioned. The length is directly proportional to the resistance of a material, which means if you increase the length of a material, the resistance will also increase. Meanwhile, for the cross-sectional area, it is inversely proportional to the resistance. So, when you increase the cross-sectional area, the resistance will decrease. Changes in composition and temperature do not change the resistivity in a simple way. Alright, so for the next slide, so let us look at the examples. These are the type of resistive sensors explained by Hafiz earlier, which are the thermistor, the photosensor, which is the LDR, and the flex sensor. For thermistor, the resistance falls with increased temperature. For photoresistor, which is also called as LDR, the resistance falls with increasing light level, which means the lower the resistance, the brighter the light will be. And for flex sensor, the terminal resistance increases when the sensor is bent. The higher the degree of the surface bend, the higher the resistance. We can see in the example below. Now, proceed to the next slide. So this is the example of sliding resistive transducer circuit. The sliding contact of this transducer mainly includes a long conductor. Its length can be varied. So the sliding contact is placed on the resistive element where the slider moves horizontally. The movement of the slider changes the value of the resistive element of the transducer, which is measured by the voltage source E. The displacement of the slider is converted into an electrical signal.
Most suitable area for the selected sensing elements to be applied in the car is engine oil and brake fluid level, which is engine sensor. So the second question is the purpose of the sensing element have in selected area are onboard oil sensors and oil analyzer. Oil pressure is hydrostatic force per unit area. Each of the oil in the engine is dielectric constant of the oil. Parallel plate capacitor separated by the oil. An oil dielectric tester correlates to the acidity of the oil and indicates the level of oil degradation. So I will pass to ALIFF for explanation.
My name is Mama Ali with Mama Yusoff. My matrix number is 200242. So today I'm going to explain the purpose of the sensing element work, which is we chose engine oil sensor and brake fluid pressure sensor. So for the first one, engine oil sensor, engine oil sensor is set up to measure the amount of oil inside the pan prior to the engine being started. So how the sensor will works, if the oil is low, it will trigger a warning light indicator on the dashboard or will eliminate the check engine light. So basically this step is very useful because we need to ensure that the engine oil is in optimal amount so that the engine will works in its full capacity. For the brake fluid pressure sensor, how it is good for the cars is because it sends the amount of brake fluid present in the vehicle's brake master cylinder reservoir. So basically when the fluid level sensor fails, it will usually display a few symptoms that can alert the driver that there are maybe problem that should be serviced. This is good for the car because this will increase the alertness of the driver in order to keep the brake fluid level in a good level to make sure that it will be ready to be used in a normal or emergency situation. The other area that can be placed sensing element are the fuel gauge. It is basically it will work the same way as in B. So that's all from us. Thank you for watching. Thank you.